All right, we've made it to our final video for this unit. Now, this is going to be our learning goal for this unit. We're going to look at how we're going to be able to relate the properties of the elements in specific groups to their similarity, in their electron configuration. So, electron configuration is this brand new thing that you guys are going to be hearing of. But again, we're going to walk our way through it, take our time, and make sure that we understand. If you have any questions, write them down. That's why we have the space there. That's why there's still room around and as well at the bottom of the page. Now, what exactly is an electron configuration? Electron configuration is the arrangement of electrons around the atom. So, when you look around your room, there's a certain configuration to how your room is set up. There may be a dresser and a bed and a computer or TV, or depending on how you have that arranged will determine how you function in your room. In the same way, as we look at how the electrons are arranged around the atom, we're able to find out a lot of information. So this is sort of like the address of the electrons that are in the atom, where they're all placed and how they're arranged. This is going to be important as we move towards bonding, which seems to be our next unit. Now, where are they located? Now, the electrons around each of the atoms are in these things called orbitals. That just basically means it's a space around the atom where we can find the electrons. There are four main types that we're going to deal with. There's the s, p, d, and f orbitals. These will be seen by just looking at the different areas of the periodic table. This part should actually be pretty easy, and if we have time, we're going to talk a little bit about, and I'll show you how to be able to write electron configurations. Right now, we're just dealing with where are these groups and how could we actually use a little bit. Now, depending on where it's located, this will tell you the orbital that the electrons end in. From this, we're able to predict bonding patterns. But as you see, we have our s orbital, our p orbital, which is here to the side, our d orbital here in the middle, and our f, and we'll talk a little bit about it in just a second. Now, our first block is, again, the S block. The S block is going to be made up of groups 1A and 2A. These are our alkali metals and our alkaline earth metals. Notice that each row in the S block only has 2 elements listed. This is because it's related to the number of electrons that each S orbital can hold. So, if we look at each row, each individual row of our S block, how many elements are there? Based on that, how many electrons do you think each orbital or each s orbital could actually hold? Go ahead and take a moment and write that down on your paper. I believe that most of you should get this part right, but again, just looking at the fact that for each row we have 2 elements. So that means in each level that we go down, there are only 2 electrons represented. So for each s orbital, we can hold 2 electrons. We're going to do the same thing as we look at the next orbital, which is going to be our p block. Now, for our p block, you notice we jumped all the way across to the other end of the periodic table. This is going to consist of your groups 3A all the way through 8A. So where you have boron, the group where boron is, all the way through your noble gases. Now, using the information on the page, or on the screen at least, how many elements are in each row of the p block? Well, let's see. I'm taking my time. Oops, sorry, got to go back. If I'm looking at here, I got 1, 2, 3, 4, 5, and 6. This means that for each p orbital at each level, I can hold how many electrons? Something to think about and to write down. Well, now we're going to take a second, move on to the next. We go now to our D block. These are going to consist of our B groups, or in the middle of the periodic table, that large group. What was the other name that we used for this group on our thing? If you remember or go back in your notes, you're going to notice that these were called our what? These are transition metals. All right. I'm just going with the fact that I believe you guys were there with me, and again, I apologize for my horrible penmanship. Now, notice how many elements there are in each row of the D block. How many electrons do you think they can hold? Take a moment, count them up. Are you ready? Give you another couple seconds. Okay, sorry, time's up. Now, for each level of the D block, or each orbital, we notice that each row can hold 10 elements, which means that it can also hold 10 electrons. We're going to bring this part back into play when we talk about bonding. So keep that in mind. And our last block that we're going to deal with is called the F block. Now, this is made up of the two rows at the bottom of the periodic table, our inner transition metals. Notice again how many elements are in each row of the F block. How many electrons do you think each F orbital can hold? Well, give you a moment, pause the video. All right, now we're back. So, how many can each F orbital hold, or each level of the F orbital hold? If you guess 14, you will be correct. Because we have 14 different elements there, that means that it can hold 14 electrons. Now, we'll play into this a little bit more as we talk about the electron and its role in the bonding arrangement, and even looking at the quantum mechanical model, which is basically the model we use for our atom today. But one last thing we want to pay attention to as we deal with our orbitals. Bringing back into play our noble gases, and you see them here and they got the nice arrow pointing to them. Now, what makes these noble gases so special? When we look at it in terms of orbitals, we're going to notice that for the noble gases, the p orbital, or that row of the p orbital, is completely filled. So it has its 6 electrons that we talked about a little bit earlier. Now, this allows it to have that ability not to react with any others. This is what we're going to continue to look at as we go throughout this little portion. It's not a whole lot we're going to do with this, so don't stress out too much. But again, start off with taking your notes. Write down any questions of things that still don't make any sense. And we're going to do more with this when we get into class. Write down your questions. Have a great evening. Look forward to seeing you. Goodbye.